Hello everyone, in the last video we used a chess analogy to demonstrate the working of classes. We learned how to create classes and we also looked at instance variables. Instance variables are simply data points that are shared by all objects of a class. So for instance, in our chess class, the player name, the rating and the color piece are instance variables. We also saw how you can create methods. Methods are simply functions that are within a class. These methods can interact with all the class objects. In today's video, we're going to look at class variables, class methods, and static methods. Understanding these concepts is essential for any Python developer looking to write clean, efficient, and maintainable code. We're going to dive deep into class variables, how class methods differ from instance methods, and when to use static methods. Unlike instance variables, which are unique to each instance of a class, class variables are shared by all instances of a class. For example, in our case, you notice that all instances of the chess class have unique instance variables, which are the player name, the rating, and the color piece. In contrast to this, class variables are shared by all instances of a class. So for every object of the chess class, the player name, the rating, and the color piece will be different, as we demonstrated down here. Whereas a class variable will be shared among all instances. A good example for this will be playing time. So playing time, this is how you define class variable. So playing time, we can give it a fixed value of 10 minutes. So 10. So in a chess game, before players can start playing, they decide on the playing time. So in this case, the playing time is 10, and the playing time is shared by all players, meaning that all objects of the chess class will share the same playing time. So that's a good example of a class variable. So you can just run this cell to demonstrate it. Also create the objects. So we run this cell. We have the object 1, object 2. So let's create this chess class and the playing time, which will be accessible by all objects of the class. So that cell has run. We can also create our new objects, and in a new cell we can access the class variables. So object 1 dot playing time. You can see that it's 10, prints out 10, and we can also get the playing time of the second object. So object 2 dot playing time, it's also 10. Another key difference between class variables and instance variables, we use self to access the instance variables, whereas in the class variables we use the class itself to access the class variables. So for example, if you wanted to access the playing time variable, it will be chess dot playing time, because it prints out 10. And you can also use this principle to set a new playing time. So chess dot playing time, let's give it a new time. For example, the players want to increase the time to 30 minutes. So chess playing time will be 30. So after setting the playing time to 30, all objects should also have the same playing time as 30. So object 1 dot playing time, you can say it's 30. Object 2 dot playing time, it's 30. So with this, we've set the class variable to 30 at the class level using the chess class, and when we print it at the object level, you see that all objects reflect the same thing. So we've set the playing time to 30 using at the class level, and you can see down here that is shared among all objects of the same class. So what if we try to do the same thing using the objects? Let's set the playing time to 60 for object 1. So we set the playing time for object 1 to 60. We can print object 1 dot playing time. And you can also try to print the second object, so object 2 dot playing time. So you notice that if we set it at the instance level, only the first object's playing time, only the playing time of the first object gets updated, but the second object's playing time will still remain to be 30. This is because the object lookup of Python prioritizes the instance. But what if we needed a way to successfully update our playing time for all instances, such that if we set the playing time to 60, all objects will have it to 60. This is where class methods come in, because we can define a class method that will automatically set the playing time to either 10, 20, 30, etc. So how do you define a class method? A class method, we use the decorator function, class method, then you can define your function. So let's set time. This will take the class itself. So class, we cannot use class, as class is a keyword, so we use CLS, and it will also take a value. Using the CLS, we can be able to access the class variables. So in our instance, the class variable is playing time. So CLS dot playing time is equals to value. So the CLS, or the class, represents the class itself. In other words, this is the same thing we did down here, where we had the class itself as chess, and we accessed the playing time. So using the class method decorator, we are able to access the class itself and set or update the class variables. So for example, this is the same thing as doing chess dot playing time is equals to value, but we are using the CLS to represent the chess class. We can try and test this using, we have defined our objects. So let's run this cell first, the chess class, and also let's create our new objects to reflect the class method. We can try and test it again. So object 1 dot playing time will still be 10. Object 2 dot playing time will still be 10. So instead of setting the playing time using the chess itself down here, let's try and use the class method. So that will be object 1 dot set time, and let's set it to 40. And we can try and access the object's playing time once again. So object 1 dot playing time, object 2 dot playing time. They are both 40. So what is the difference between this class method and this instance method? The instance method interacts with the instance variables, which are the player name, rating, and the color piece, whereas the class method interacts with the class variable. A good application for class methods is when you are trying to create dynamic constructors. For example, in our case, when we instantiate our objects, we just pass the name, the rating, and the color piece. But let's say our objects have evolved over time, and our clients want a way to pass these details, which is the name, the rating, and the color piece, as one string. This would look like as object 3 is equals to chess, and they want to pass something like Kevin as the player name with a rating of 1200 and a color piece of white. So as it stands right now, it won't run correctly because we need a way to split this first name, the rating, and the color piece, and instantiate our object to the correct player name, rating, and the color piece. So we can use class methods because class methods interact with the variables at the class level. We can use class methods to define alternate constructors. So for example, we can have a class method right here, class method, then define our function. Let's call it from string. This will take class at the first instance. It will also take the string. We'll then split the string into 3 parts. So string dot split. I'm going to split it using the hyphen, which is the hyphen over here. This is going to return 3 objects. So it will return the name. It's going to return the name, the rating, and it's not going to return and it's also going to return the color piece. So color. And from this, we can instantiate our object. We are going to return the class as the name, the rating, and the color. Okay, let's run this cell and test it. So down here, where we have our object 1, object 2, and object 3, we're going to say chess dot from string, and we are going to pass a string which was Kevin, a rating of 800, a color piece of white. So we can run that, object 3. So object 1, you can get the player details. So the player details. Player name is Bob, rating is 1500, color piece white. Let's test for the object 3. So object 3 dot player details. And here we have it. Player name is Kevin, rating 800, color piece white. That's just another application of class methods, which are very powerful, as you can see from here. That's it for class methods. Static methods are simply utility functions. They don't interact with the class instances or the class variables. As I say, they're just utility functions. So for example, we can create one static method just for testing. So at static method, we can write a function to check if the rating belongs to a beginner, an intermediate player, or a grandmaster player. So check rating. It doesn't take cell for the class. Just take the value, let's say the value, or let's call it rating just for clarity. So we're going to take the rating, and it's going to check if the rating belongs to a beginner or an intermediate player or a grandmaster. So if rating is less than 400, return beginner. Else if rating less than 800, return intermediate. Else if the rating is greater than 800, return master. So we're going to run this cell, create our objects, and we can test our static method. So I can say object1 dot check rating, and the value is object1 has a value of 1500. The rating is master. And that's it for static methods. Static methods are basically utility function. They don't take self or the class as an instance. So that's it for this video. We've looked at the workings of class methods, static methods. We've also seen the difference between instance variables and class variables. So the next video, I think I'm going to look at inheritance. Yeah, that's it for this video. See you in the next one.